to have one source of truth, so one place when you will put all your data in order to cover all your analytic use case, going from data exploration to high volume ETL to BI reporting, and also doing ML or just data science. So this is the concept of lakehouse, one place to fit all the use cases. And put simply, the lakehouse is somehow the marriage, the successful marriage, I would say, of the best what we can have in the data lake and the best that we can have in the data warehouse. And this is why, and this is the reason why many of our customers who started, for instance, on the data lake are progressively moving to migrate to the data warehouse. So today at Databricks, we are having different tracks. And myself, I am part of the migration team covering EMEA and APJ. So I'm working a lot with customers migrating from Hadoop. Will it be Cloudera? Will it be HotonWork, MapR, or sometimes even open source Hadoop? We have also some customers migrating from EMR in AWS to Azure sometimes. Okay. On top of that, I'm also working on projects migrating Oracle, Teradata, Netezza, SQL Server. So a lot of customers are willing to migrate to the lakehouse. When I say the lakehouse is an architecture built around Databricks, but not only Databricks. In every cloud provider, we build the architecture lakehouse together with the other cloud components. We have also cases where customers also migrating from SaaS. A lot of customers today are using SaaS for ETL. I'm meeting a lot of customers every week where they would like to migrate either the ETL part, data prep part from SaaS to Databricks. Okay, so tomorrow we speak about ETL, the day after Enterprise Data Warehouse, but today is Hadoop. So I pass the ball to Jose from Microsoft to discuss about what are the ways in Azure to migrate from Hadoop into Azure. And Avanad will speak about a successful customer story. Thank you. And don't hesitate to ask all your questions using the capabilities of ON24. Thank you.
Thanks for passing me over. Well, I'm Jose Mendez, a global cloud solution architect from the Microsoft Global team, and I'm going to introduce you into the Hadoop migration workloads to Azure. So what are the key reasons to consider the departure from Hadoop on-premise? After all, Hadoop server consumers for more than 1 decade. A decade ago, Hadoop opened undoubtedly a new era in data processing. Thanks, back then, unprecedented scalability and handling unstructured data and cost effectiveness, to name just a few. But fast forward to today, Hadoop on-premise is at an inflection point, and many of its customers realize they have to pause and consider their option, either because they are using old versions of HortonWorks or Cloudera that are soon going to run out of support, or they are perceiving that on-premise Hadoop only partially delivers on its promises, and this is very much related on its complexity and stability, with not clear path forward to reduce that. A good place for those resources and clusters is the innovation and degree of agility that every enterprise expects for itself to accelerate and increase. Every industry is facing new challenges that are not fit for on-premise Hadoop any longer. In the telecom industry, this may be the increase in the data to be analyzed thanks to adoption of technology like 5G. In the retail industry, this may be the increased need for online shopping driven by COVID, not to mention IoT, because ambiguous and generating every increasing amount of data that are hitting the system at every single speed and need innovation approaches to process any analysis. A direct consequence of above cloud capabilities are the cost savings that can be realized compared to on-premise world, leveraging an example of scalability, elasticity, and so on and so forth. Also worth mentioning the operational efficiency resulting out of the cloud transition. On-premise Hadoop, thanks to its complexity, has always required a significant amount of resources and work for mundane infrastructure and configuration chores that were needed just to keep the lights on. Cloud relieves Hadoop customers, depending on approaches chosen, of many of the chores, allowing refocusing resources dedicated to that. Other reason is that they stay in on-premise, you lock yourself away from the benefits of the cloud. Cloud technology has developed in the recent year considerably fast than on-premise or other environments and solve several important challenges that are not addressed by Hadoop. Storage compute separation, the ability to scale them independently, the capacity, the elasticity are probably the most important of them. While we should also mention enterprise readiness about high availability, disaster recovery, security. For example, while in Hadoop many days topics were addressed later in the life cycle, so Azure Cloud and every solution in it was being designed with the enterprise access considered upfront. That is key for migrating the Hadoop workloads. So let's gonna deep dive a little bit more. When we talk about a Hadoop migration, most of the times we are talking about an on-premise migration to the cloud. Some of the most popular services that we can find on Hadoop ecosystem are Spark, Hive, Impala, HBase, Kafka, and MapReduce jobs. As a main storage account, and similar to HDFS, that is the Hadoop storage service, we have Azure Data Lake Store. This service will be the core component to the whole Azure ecosystem. As well, new services will use this to store and transform data. Services that we will use for the migration have different purposes and capabilities. Databricks as the data lakehouse, is the Insight as the PaaS service for Hadoop, Synapse as the main data warehouse, and Cosmos DB as the document DB, for example, and last, Event Hub as Kafka services for the stream workloads. The three migration paths that we have for this scenario are: first one, lift and shift, where we are just changing the location of the cluster. Could be platform as a service or could be infrastructure as a service. Second one, technology switch, where we have different Azure services for the Hadoop ecosystem that we have. Third one, reengineering. Here, what we are doing is just changing completely the technology that we are using from one Hadoop ecosystem to another services, such as Synapse, Databricks, Cosmos DB, or others that we can find in Azure. So let's deep dive a little bit more on this topic, and let's see the different paths that we have for the migration approach. Unfortunately, there is a wide range of options to select from your Hadoop to cloud migration strategy. Depending on your business objectives, risk tolerance, resources, and skill set, you can choose to migrate or replatform your current system while continuing to use all or part of the Apache data processing technology that you are familiar with, like a Hive, Spark, HBase, Impala, Kafka, and so on. For very many use cases and on-premise Hadoop deployments, avoiding a technology switch altogether is an achievable option. Many of the older platform owners, under support expiry deadline pressure, may need to consider one of these, while others may evaluate such option because of the huge Hadoop skill set already accumulated in the organization. Such a non-technology move can come in many flavors: infrastructure as a service, platform as a service, software as a service, each having their own merits and drawbacks. But common characteristic is that assumes little to moderate adoption effort from the application developer and productionize on-premise. No technology switch can be also executed at first of a multi-step migration plan, taking off the time pressure and allowing for a well-architected planning and execution of more ambiguous approaches. The no-technology switch option can be driven by several reasons, and depending on your current use cases and technologies, some of it may have to be done anyway. Several of the other on-premise components, such as Flume, Pig, to name just a few, are being discontinued by the community. There are plenty of applications on-premise clusters that could be benefit from more modern technologies that did not exist when they were born. Hive, for example, to Spark ETL conversion. But the most frequent reason for technology switch, there will be a superior cloud-native option to be better address the same use cases that Hadoop on-premise runs. Last but not least, bigger the risk, bigger the reward option to be mentioned is the re-engineering into a modern cloud data warehouse and big data platform. There are a lot of old Hadoop on-premise deployments that have accumulated a significant technical debt over the years that could be cleared. Many of today's Hadoop's implementation, that because was a fashionable analytics better suite for relational MPPs technology. This about do create an opportunity window for engineering in many organizations. As we can see in the picture, we have for lift and shift IaaS infrastructure as a service and platform as a service, where for IaaS we are talking about virtual machines. For PaaS we are talking about mainly Databricks Spark and Azure SD Insights. When we talk about technology switch, we are rewriting the code and the technology, but what we are doing is a common transition and a great transition from the different services that we have in the left-hand side. Spark is based in Palamaris and Kafka and Flume, to Spark Databricks, Cosmos DB, Databricks, Spark Databricks, and Azure Event Hubs and Databricks Structured Streaming. Whereas in re-engineering, what we are doing is to transform the whole services of CDH and HDP clusters into a new modern data warehouse or big data pattern, such as, for example, in Databricks, Cosmos DB, Event Hub, or could be Synapse, for example. So those are the ones that we are covering for the migration path. So with that, I finish my whole presentation when we talk about Hadoop on-premise to Azure cloud migration. So I'll handle it and I pass the ball to the next speaker. Thank you for your time.
Thank you, Jose Mendes, for a great introduction there to migration pathways. I'm going to cover migration pathways a little bit later in our presentation piece when we talk about our migration factory and some of the cookbooks, and also about some of the workload identification. But before I get to that point, maybe start with an introduction. So this piece is around legacy migration, and I'm going to be talking about specifically Hadoop migration to Azure. And that will involve some Databricks and some other things. And I'm going to use some client examples as well to hopefully reinforce some of the points that I'm trying to make. This section is migrating legacy data to Azure Databricks with confidence. And that's something that's quite difficult to do because anybody that's involved in data migrations will tell you there's no such thing as an easy migration. All migrations are difficult and complex for one reason or other, whether that's politics, whether that's data, whether that's the system integrity or integration, or the fact that things are on 24/7 collecting data, processing data. You've got to try and move those about like doing open heart surgery. So my name is Tony Slovitt, and I work in our Global Azure Center of Excellence as the Data Platform Modernization Lead for our global team. So I'm going to start by setting the market context and key queries that we often get when we're doing client migrations. Then I'm going to touch on Azure Migration Factory, or Data Migration Factory, give an overview of that, and talk about the Databricks pathway. This is a specific pathway of moving any form of Hadoop capability to Azure, and in this particular case, Databricks. And what are the typical migration challenges that we see, and how do we mitigate those? I'm going to talk a little bit about our cookbooks and give you some examples or a sneak peek of those cookbooks. I'm not going to give away all of the secret sauce. I'm just going to give a flavour of what's there and what good looks like. I'm also going to cover our migration methodology. The migration methodology is really quite an important step because it actually lays out the things that you need to do in order to be successful in a Hadoop migration to Azure. I'm going to cover our reference architecture for Lakehouse, and that includes obviously Databricks workloads because it's Lakehouse, but also other service capabilities such as Azure Synapse. And I'm going to finish with some success stories and touch on some of the key points from our experience of working with clients and doing successful large-scale migrations to Azure. So in terms of market context, there's a few sort of statistics that I wanted to touch on. The first one is about the number of companies, or the percentage of companies that are able to realize value from data. It's a very low percentage, 32%. So this is either data isn't being measured correctly, isn't being used correctly, isn't being evaluated correctly in many data platforms or in a single data platform. And this doesn't necessarily relate just to Hadoop migrations, by the way. This is data platforms across the board. And according to Forrester, 60 to 73% of all data within enterprise organizations goes unused for some form of analytic purpose. So those two kind of coexist, or at least correlate. The most important one, specifically for the subject of Hadoop migration, is around 83% of all migration projects either fail or exceed their budgets or schedules. And this is quite a common statistic, and it's something that we commonly see across client projects. And it's either a misunderstanding about what's needed, the amount of effort that's needed on the client side of things. Sometimes it's simply the interaction between parts of the client's organization. Okay? But 83% of all migration projects either fail or exceed their budgets or their schedules. Okay, and I'm going to talk about migration factory in just 1 second. That's kind of how we deal with things. So it's a practice or a pattern for how we deal with things. Now, when we talk about key queries that we get from our clients, I'm going to pick a few here rather than read the slide to you. So can selected data be migrated? Can we pick some of this stuff and move it? Is some stuff more important than others? Certainly the answer to that is it depends. But it is yes. Generally, you can select a set of data and migrate it. You may choose to migrate the data that's currently being processed and leave the historical data in place, or move the historical data, or do those things at different times. Okay. How can we be assured of the right migration planning? That really comes down to the methodology and the approach that you take. That honestly, if you take the right approach to doing this, which is understanding it before executing it, then you're going to be in a much, much better place in terms of migration planning. And finally, can code conversions and data migrations between systems can be easily performed and keeping the right RTO and RPO in place? Well, the reality is that when you move, even if you're doing a like for like or a lift and shift, you're not going to be maintaining the same RTO and RPO objectives. You're going into a different set of infrastructure. You're doing things in a slightly different way. You may even have more extreme RTO or RPO needs when you move to a cloud factory or a cloud data platform. So you need to consider, actually, are they the right thing? Do they need to be changed? And it may be that they need to be changed for certain elements of the data platform, such as the ingestion or the landing zones, the storage and the processing, how these things actually get dealt with in terms of RTO and RPO. So here is how we at Avanade deal with data migration. We use an Azure Data Migration Factory. And our factory model, without wanting to turn this into a sales pitch, is really just a best practice, or at least a good practice method of pulling together all of the different tools, the different capabilities, the methodologies, the solutioning, pulling all of that together in one way to increase the speed of migration. Because one thing that does tend to happen with data migrations is they take a long time. They take far longer than the client expects them to. So we aim for between 1.5 and 2.5, so we say around about 2 times faster migration using other alternative approaches. We've also invested quite a lot of effort and time and effort in our migration cookbooks, and I'm going to touch on the cookbooks in just a bit. It's around 20,000 hours of expert time from both Avanade, Accenture and Microsoft product engineering teams into these cookbooks to make sure that they're there. We also have over 45 industrialized migration pathways. So if we talk about Hadoop to Databricks, that's one pathway, okay? And again, when we're talking about Hadoop to Databricks, there's a lot of stuff in there, you know, like Oozie, Hive, HBase. All of those have some form of a sub-pathway that they need to follow in terms of a technology transition from one platform to another. So we're talking about the process itself, so Hadoop to Azure, or Hadoop to Databricks as an example. And here's our Azure Data Migration Factory on a page. We're covering from the data advisory and strategy through to managed service. As I said on the previous slide, we aim to do a migration 2 times faster than if a client was trying to do it themselves. We have hundreds of clients, of projects, and thousands of professionals as part of that. And the migration pathways that previously talked about, for instance, as Oracle, Postgres, Hadoop to Azure Databricks, which is the one that we're primarily talking about today, SQL Server, Netezza, Teradata, and then some of our partner ecosystems, part of the tooling and the service capability that we also have with both Microsoft and Databricks as primary partners, and also some of the other partners such as WANdisco, BladeBridge, and Unravel. Now, looking at the specific Hadoop to Databricks migration pathway, what we've done is simplified the diagram somewhat. There are some far more complicated diagrams behind this, but using 2 fairly straightforward industrialized pathways. And that's either moving from Hadoop, and that's all of the workload capability, it doesn't matter what the technology is, to Databricks. Some of that requires effectively rehosting, but in most cases, it's a matter of refactoring and rebuilding. And that's the simplest method for getting the best value. Even though you're taking it from Spark to Spark, there are still some things that you need to do around the edges in order to do that. And I'll cover some of those in the typical migration challenges on the next slide. One of the other things you might want to consider doing is optionally, or at least temporarily, workload rehosting. So you might want to actually take some of the on-premise workload and rehost that in HD Insights, Azure HD Insights. Obviously, in order to do that, you may also need to go through some upgrade path as well. There's some devil in the detail, as there is in every migration project. But by doing that temporary hosting, it allows you to get off of the on-premise platforms. And one of the things that we often hear from clients, is that there is a really dramatic end-of-life event occurring with the on-premise Hadoop capability. And that's usually because of licensing and the license escalation costs. But sometimes it's about capacity and scale as well, and about new workloads that are coming in. So we want to move all of this because of the cost. We want to get it off the on-premise as soon as possible, but we also want to modernize and move at the same time. So you end up doing multiple migration movements in a single migration project, and that is actually quite typical of Hadoop platform migrations. This temporary workload rehosting is I think, a nice balanced way of getting off of the on-premise infrastructure into the cloud, and then allowing you to do some rebuilding or reworking of that once it's in the cloud onto native Databricks capability. Now onto the typical migration challenges that we see with Hadoop migrations to Databricks. One of the first things that we see is that, when you talk about Hadoop migration, doesn't matter which brand or flavor of Hadoop we're talking about, we're not talking about a single technology or a single capability. You might have, Uzi workflow, you may have HBase or Hive workloads as well. And I'll come and talk about analyzing or understanding the technical workloads a little bit later, but understanding what those workloads are. And it can be quite a complex ecosystem. And also, if the platform's been in place for some time, you may actually have multiple things doing similar capabilities. As I said, workflow, scripting, batch scripts, other things that are getting triggered in a particular way. And these are things to look out for. As I said before, the devil is always in the detail in these particular things. You'll also, one of the other typical migration challenges that we see is stringent migration timelines. As I mentioned previously, the end of life of on-premise platforms really focuses the mind when clients are looking at multi-million euro, dollar, pounds cost just to relicense the Hadoop platform for another year, for instance. And these things tend to focus the mind and clients then ask the question, why can't we get off this platform quicker? We need to get off this platform as quickly as we possibly can. Target state is another typical migration challenge, choosing the right one. We often get into situations with client engagements where clients want a perfect finished architecture up front. Honestly, in a modern data platform, there is no such thing. It's an evolving capability. So what you decide to do is you choose the right architecture for the right workload, and you may choose multiple, and also multiple approaches, as I said in the previous slide. Rehost versus refactor versus rebuild. You may end up doing all three of those, or even a fourth one, another arm. So you've got to factor these things. It's a multi-dimensional chess puzzle that you have to try and resolve. And at the same time as migrating, you need to look at what the new business requirements are as well. Often clients will pause new work whilst the migration goes on. And what you're really doing is reducing the value to the business by doing that. What you want to try and do is balance the old workload or existing workload or even legacy workload with new workloads, so the client can get better value from the platform quicker. The actual data migration is also can be challenging, especially when we're talking about data platforms with many terabytes or petabytes of data, of historical data. And it may be that some of the historical data can be archived. It probably can't be deleted, but it might be able to be deleted. And these things all need to be challenged. When you're looking at a migration project, it's like, how important is this data? What's the gravity of this data? Without this data, what would that mean to the business? So actually looking at the data that you have in terms of historical content, and also in terms of what you need it for. You know, do you need all of the historical content from day one? So when you try to get stuff off the platform, could you lift and shift the historical data to a temporary location, move the day-to-day in-progress capability so that you have a processing engine or a data platform that's actually processing new data or existing data, and then merge them at some later point. Thinking about how you actually move that data and at what time, you can usually come up with some nice creative options. And that also introduces some interesting cutover strategies. If you're moving historical legacy data into your new data platform, running on Databricks, probably a Delta Lake, how are you moving that? When are you moving that? At what point are you going to be able to report this information together if you are using a lakehouse and you need all of the data there for analytical reporting, for instance? You've got to factor some of these things in when you look at the data migration without overcomplicating the picture. Change management, and I really can't stress enough here the challenges around change management. And often in client projects, this is the most challenging area. And what you'll have is you'll have potentially upstream and downstream systems or providers and consumers, if that's the language that you use in your organization, where data is being provided or pushed into the data platform or pulled into the data platform. It's then being processed, homogenized. Something is refining the data in the data platform itself, and then you have something consuming that, whether that's an application, whether it's going into a database, a data mart, for reporting, for a data warehouse, or a BI workload. Whatever the need is, you've got to actually factor in the entire end-to-end food chain to make sure that you are actually doing the right thing in terms of migration approach. So do you have all of the correct stakeholders involved in the project? You don't want to involve them too late, because then it will rush the party and it can often cause problems. You also need to factor in security and infrastructure. We're moving from an on-premise Hadoop capability into the cloud. This will include a whole bunch of additional security capability and things that are needed in the infrastructure to make sure that you have, such as point-to-point network connections, private endpoints, obviously security that comes, that is a given. It's entirely possible that you'll have multiple Azure Active Directories, one that's Azure Active Directory, one that's on-premise, and you have to look at ways of actually merging those together or connecting those together. One of the most important things in terms of data migration is probably network bandwidth. We often get into situations with clients where they have a big express route to Azure, and we want to use that for the migration, but that same express route is being used for many different things. It may be that actually some form of network prioritization or time framing. So, we can only move historical data overnight or during certain periods of the day, and we have XX bandwidth available. These things need to be factored in. Another challenge is around resilience, and this isn't really just resilience, but this is also the migration resilience. So during migration, when you're moving stuff from A to B, or A to B to C, you are actually taking multiple steps, and you have to actually factor in multiple things. What we often see, for instance, with clients, if it's a data platform that's doing some form of data manipulation with providers and consumers as a capability, then you need to look at potentially running side by side or parallel running of the on-premise platform and the cloud platform for a period of time. And that allows you that transition of stakeholders or applications as well. So all of these things need to be factored in, and also rollback points need to be factored in as well. So if you are doing that, something goes wrong, at what point do you roll back? These elements need to be factored into the plan. Now, we address many of these challenges, or mitigate many of these challenges, using our cookbooks. Now, migration cookbooks, which relate to the particular pathway that we're working on, in this case, Hadoop to Azure Databricks. And the cookbook contains many pieces to it. That relates from methodology through to data reconciliation or data migration, which also includes a number of toolkits, architectural blueprints, assessment, either assessment approaches and tooling, or the entire thing combined, and workload migration. So looking at what a good workload migration strategy would be. Often there are dependencies in your workloads which you have to factor in. We also have infrastructure and security capability with our toolbox, the Data Factory. This is automated scripting for row level and column security. There are a number of other tools which we have in our toolbox for reconciliation, comparison, statistical information, and other things as well. When we look at target state, we have decision matrix and tool evaluation matrix, which effectively allows us to assess the target state to make sure that it's fit for purpose based on the requirements of the source. And here's a sneak peek at some of the pieces of the cookbook that I just referred to. There's just historical incremental data migrations. These are methods or approach or flows that you would actually follow in order to assess the best way of doing historical and incremental data migration. Some performance and benchmarking and testing using TPC-DS performance benchmarking. So what you can do is make sure that the architecture that you're building is actually working at the performance that's needed for the platform, for the workload. The tool selection matrix. Some of the things that we look at, for instance, HDFS migration, what the target state might be, and then there are some tools and other things which actually relate to each one of these states. So whether it's HDFS, Hive, Spark, HBase, whatever that happens to be, what it's going to. One of those, for instance, on a client project I'm working on right now, is actually HBase to SQL. That's a particularly complex thing because you're going from NoSQL to SQL. But in this particular context, it works for this particular client, for the workload that we're actually looking at in that particular instance. That's not listed on the slide here, but it is part of our tool selection matrix. And then a simple flow, which actually helps you decide, should we go phased versus big bang? And again, there is a slight misnomer around phased and big bang. Big bangs are often phased. You may do multiple larger bangs in order to get there, or some form of phasing or grouping, which may relate to the way in which data is provided. So maybe from the provider's perspective, the type or nature of data, the frequency, so whether it's batch overnight from a particular source or near real time from something else, you may take multiple approaches. It may be that you big bang the historical data, and then we do a phased implementation of the day-to-day processing, so the actual processing capability or ingestion and other things such as ETL. That's just showing you some of the secret sauce. As I said right back at the beginning, I've probably mentioned it several times since, migration methodology, this is absolutely key to the success of any migration. And we follow a simple, similar migration methodology for every client migration project with our migration factory. It starts out in the first phase of discovery and assessment. And this is really quite important, and I have mentioned it several times. Understanding what the workloads are, what your data are, the nature of the platform, the Hadoop capability that you're running. So it's not just getting a list of, we've got these services running, we've got some Uzi, we've got this, we've got that. It's actually going another level down and saying, right, of my Uzi workloads, of my Hive workloads, what are they? What's providing or consuming information? How are those things being or working right now, working together right now? How do these scripts hang together? Are they just shell scripts which are triggered by Uzi? How does this actually work in reality? How would that work in a Databricks on Azure environment? Because there isn't sometimes a direct correlation. You can't just pick the script up and go, ta-da, it runs on Databricks on Azure. Because you may need to do something around it, especially when you're calling from script to script, where you have controlling or management scripts that are then calling child scripts. These things will have to have some form of refactoring when you move to the target environment. So it's important that you do the right level of discovery and assessment up front. That's not just looking at the infrastructure and the technical workloads, it's actually looking at the data workload. So what is it that's actually running there? What are the named providers? How often, how frequently do they deliver? So a full data catalog or a data inventory will actually help you make the right decisions, looking at the architectural blueprints from the source, but also to the target. We also step through the migration decision tree, which actually helps us with the frequency, the phasing, and all the other decisions. And once you've completed discovery and assessment, you're on to strategy, design, and plan. And this is where you're looking at how the migration is going to work. So which bits go in what order, what scripts are needed, what tooling is needed in order to make these things happen, and the automation, and that's really vital. A good migration and our migration factory is absolutely dependent on automation as much as possible. So we automate everything that's possible to automate, and that comes down to data testing, validation, script implementation, migration of particular tables of database. So for instance, from HBase to SQL is the example that I gave earlier, and validation of those things, making sure that we actually have those fully automated, because that actually helps with runbooks, because you can actually put into a runbook, here's my migration script, here's my automation points, and the validation as you actually run through that. And it actually helps with the cutover strategy and also with what's known as implementation templates, so the things that we need to do in the right order in order to be successful. And when you group these together, that can actually help you then with your phasing and your phase approach. Then, of course, there's the execution of the actual migration, or the movement of the data and the movement of the technology of the data platform. So from Hadoop into Azure Databricks. And that obviously includes things like testing. You can't test enough when it comes to Hadoop migration from on-prem to Azure Databricks, making sure that you're getting all the elements correct, including things like load testing, which you may not call it performance testing. You want to make sure that the load of data that you're pushing through the system, you're getting at least equal performance from on-prem as you're going to get in Azure. And people go, oh, of course you will, of course it'll be faster. And that's not necessarily the case. You need to look at the individual cases and make sure that you've got the right level of performance or load capacity. As I said before, in order to do this, we have a number of migration templates, a whole bunch of tools and accelerators, including some of the assessment tools that I mentioned earlier, such as Unravel and BladeBridge, and the two elements that help you assess both workloads and code, and a number of migration cookbooks. So, for our Hadoop migration to X, we have 8 migration cookbooks in this particular case. And what we do on each migration project is we feed back into that. So it's a continuous learning and innovation. We're always refining things, refining scripts and other capability. So long as there are no IP provisions in place that prevent us from doing it, we will then harvest and relearn and continuously improve and innovate. And here's a diagram of a Hadoop migration process flow, or a typical migration process flow, where we're taking from the Hadoop ecosystem, metadata tables, job metadata, other information, the data from HDFS, moving that data. And again, that movement of data may include tooling such as WANDisco, Live Data Platform for Azure, or some other script capability, and maybe even some other tooling that we have in our toolbox, or ones that you already have in place, with either full load or incremental load. Loading the data and making sure that the toolbox to extract the metadata and actually convert everything into the correct target compatible script. And don't forget, of course, the historical data load. Historical data load will generally be a much larger movement of data, and there may also be some repurposing. So, for instance, on Hadoop on-premise, many of the file formats were in ORC format. When you move those to Azure on Databricks, moving it or converting it to Parquet format would be a really good thing to do. Obviously, when you do that, there is some conversion. So there may be multiple copies of the files. There's some conversion that's needed. There are also some interesting issues with data types from ORC files to Parquet, where there isn't a direct conversion. So just some things to factor in when you're looking at the historical data migration, and then obviously moving the schema itself for all of the running jobs. Just moving this, even in a lift and shift, it requires some amount of refactoring or rework. And I don't want to scare you. This isn't a kind of you have to rebuild everything, but there is some tactical work that does need to be done properly in order for it to execute correctly in the target environment. Now, want to finish this section of the presentation just by stopping and looking at a reference architecture for Lakehouse. And this reference architecture, this is actually from the Microsoft published blueprints and architectures, which is one that we follow. Obviously, in the reference architectures that we use, there's a little bit more depth to this, but it's in principle the same thing. We have the Databricks capability in the middle. You may also have Azure Event Hubs if you're doing near real-time data collection. And again, there may be some Databricks components in there, and Azure Data Factory. And again, you may choose to use some of the legacy or on-premise Spark code in Databricks notebooks within ADF. These are kind of typical patterns within a standard architecture. They still fall within this reference architecture. And that comes into a Delta Lake and a Lakehouse capability. And then you may also then use Synapse Analytics as a really good SQL processing front end for reporting, data warehousing and other things, just using Lake database definitions in Synapse. There's some really, really powerful capability. And in actual fact, this is a typical pattern that we see for things like Hive, where there is some Hive data or Hive capability or workloads taken from on-premise Hadoop, moved into Azure Data Lake or Delta Lake, and then have Synapse sitting as the Hive query or the HQL replacement in the target architecture. And this doesn't require a lot of thinking about, but you still need to make sure that you've got it right, to make sure you've got all of the right data, either the ORC files or ORC and Parquet files if you are going to convert them as well. So you've got to make sure you factor all of these things in to ensure that the consuming or the application workloads are actually seeing the right data in the right way. So I want to finish by looking at some client references. I'm not going to drain this slide. I can leave you to read that at your own pace. But if we look at the first one, a leading health insurer operator in the United States, and this is a migration of an extremely large data platform. In fact, it was many data platforms into a single data platform. There were several Cloudera data lakes that we migrated to a single Azure data lake with Azure Databricks. And with around 2.5 petabytes of data and 100,000 tables, it was an extremely large endeavor. We managed to do this with the Migration Factory in around 12 months. The original assessment that was given was approximately 2 years, at which point the client said, we need to make this go faster. And that was simply because the license cost of all of that infrastructure and all of the capability on premise was eye-watering. But that was a very large migration. Another one that was very interesting is a US leading financial organization. And that was essentially to enable the enterprise data lake. And I mentioned previously the migration of existing legacy capability is great. The client gets some value from that. But what you want to do is actually look at driving adoption of new workloads and new capability on the target platform, therefore getting value much, much more rapidly from the platform. And this is a particular instance of this. This was actually enabling an enterprise data lake. And we split this down into 3 waves. The first one was effectively to build the target architecture. So we built the target Delta Lake and Azure Databricks environment in order to enable the support, but also the early workloads of the capability that they actually needed for analytics workloads and for business intelligence. In the second wave, we drove adoption of the enterprise data lake. And this was both taking the legacy data warehouses. And what we did is we did an assessment of all of the legacy data warehouses to see which ones needed or wanted migrating, or whether the data needs to be moved, what the level of reporting was actually needed from those data warehouses that they already had, the legacy data warehouses. We then enabled new workloads in the platform using some of the legacy data and actually drove that forward. In fact, the prioritization of the legacy data warehouse migration was driven by the priority of the new workloads going onto the platform. We leveraged the foundation to execute against the existing or the new need for the client. Interestingly enough, in this particular instance, is one where I think I said at the beginning, you don't delete or throw data away. This particular client, we only migrated around 36% of their workloads in 1 year, and that was based on prioritization, but also around importance. What we actually found was around 60% of the data that they were storing, or the storage space that we were using, was effectively wasted space, duplicated data, and in some cases, stuff where it's just collecting data into a warehouse that was never used by the analytical application, and had no real purpose for the organization. So that allowed some additional deprecation. So that's the end of my piece, and I'd like to thank you very much for your time. Hopefully you've got some value from what I presented today. I also want to thank Mina and Jose Mendez for their contribution to this presentation. And what I'd like to do now is open for live Q&A. Thank you.
Hi everyone. Well, hi everyone. Thank you for being here. Thanks, Jose. Thanks, Tony, also for being here. So we have still 10 minutes left. We can still take some question live. So please use the Q&A inbox as you used when we were presenting. So one question we had during the presentation is that on average how much project will take. It depends really on the scope. It's really depending on the scope of the migrations. It depends on the tools you are using to migrate. So it's really hard to answer this question. But usually, if you are working only with Spark, migration will be easier compared to if you are using, for instance, Pig, like one of the questions were asked earlier, or other similar solutions, like if you are doing orchestration with OSI, maybe this will take more time to convert. One of the other the question they were asked is about the level of compatibility between Hive, Impala, and Databricks SQL. Most of the time, we have a compatibility of 90%, 90 to 95%, because most of the time customers are using Hive and Impala for data transformation, and scarcely they are using UDFs, because if you are in Hive, you're building UDF in Java. If you are in Impala, you'll be building UDF in C++, and from the hundred of customers be working with, scarcely they use this kind of capability. So most of the time, it's SQL, I would say, language, which is very close to SQL in Databricks. So most of the time, migration also from Hive and Impala is quite as smooth as migrating from Spark. Okay, so I can see some other question here. Is an official roadmap that shows what will be GA at what time? So official roadmap, yes. If you are speaking about Databricks, yes. I think we either we had or we will have sessions related to our roadmap. So maybe Linda can send some information about that when sharing the recap of this session. What will be the next dates? We will be sharing roadmap with our customers and prospects as well. Okay, thank you for presentation. So where can we find this registration upload afterwards? Yeah, so marketing team will make sure you will receive all the materials in the next couple of days. Is there any customer using Databricks installed on premise? No, because Databricks is only available in the cloud. We don't have a deployment on-prem. Let me read the question here. Oh, yeah, so we have a question here about security. Okay, so here, if I can read the question, yeah, but sometimes questions are asked. It's not just about the data, not migrating the data or just migrating the workload, but it's also about how we set up security once we are in the cloud. Others speaking about resource-based access, about access-based access. So maybe, Jose, you would like maybe to say some words about how we can implement security in the context of Azure and migration.
Yeah, basically this is some of the challenges that we can find, because we are thinking about different technologies and different approaches, not just for data. This is the main point, actually, but also sometimes we don't think about the different challenges that we can find when we migrate, for example, role-based access control, attribute-based access control, or ACLs. That is the most common thing that we need to find. So this is some of the kind of thing that we are doing, and we are migrating from Microsoft and with the support of Databricks teams and Avade as partnership.
Yeah. So
maybe I can add just something on that, because this is something we do see some challenges with, especially with clients where they have some particularly complex range of policies, and they're mapping that to RBAC in Azure Data Lake. It's quite complicated. It's something that you need to spend, I would say, a fair amount of time looking at, right? And often we'll encourage clients to change the way in which the range of policies have been applied. So typically what you'll see in a large scale data ingestion scenario, as an example, with on-premise, with range of policies that are based on some form of a control mechanism or user-based policy, or even by parts of the organization. So simplifying that so that you're actually applying the right level of access in RBAC in Azure Data Lake, and simplifying it to make the migration project simpler to achieve. It can be quite burdensome, right? We're in situations with some migration projects where, you know, just this subject alone can take many person months of effort to resolve, where in actual fact taking a slightly simpler approach and removing some of the complexity before you start the migration, I believe is the right way of doing it. It may not be entirely practical in every single instance, in which case you'll have to accept some form of compromise, not to security, just to the way that the RBAC policies are applied.
Okay, so someone is asking about the training available. So yeah, so we have training available, not exactly what you have covered here, but enough to have enough experience on migration to Databricks on the Databricks Academy. Okay, so if you are a customer, you should have access to Databricks Academy. If you are not, we have sessions where we have introduction to the Lakehouse, we have introduction to the Databricks platform. So those are still valuable if you would like to start ramping up on Databricks with hands-on experience. Okay. Now I have a question with Jose. So it's a long question, but I can summarize it. So basically, the question says, when should we use Event Hub? So we are in a streaming scenario, and when should we use between Event Hub and IoT Hub? What is the right scenario for the first? What is the scenario for the second?
Basically, I mean, sometimes here in Microsoft, we are wrapping up things depending on the use cases and the patterns. So basically, when we talk about Event Hub, is as the name said, is for events. But it's not, I mean, it's a priority because in the end, we are using Kafka under the hood. But basically, it's more focused on events for streaming analytics, for example, as is the common pattern for Kafka. But whereas we are talking about IoT Hub, is more focused in IoT. Let's say we have so many devices getting some value and sending some values to the let's say to a storage account, and then we are processing this into IoT event hubs. IoT hubs, sorry. So basically, it's different use cases because we are talking about IoT, and the other one is for events for example, a migration approach, or for example, for different databases that we are getting information and we are detecting different patterns and events. So this is the kind of approach, and under the hood, what we have is different clusters and different architecture. But in the end, it's the similar service. But as here in Microsoft, we are wrapping up things in different use cases and approaches. That's the main reason, because we have also SD inside Kafka. So in the end, we have similar services with different approaches and with different names, because we are more focused on the use cases and the patterns and the industries for the customer that we have.
That's good. That's good to know. Me too. I wasn't clear about the difference. So thank you, Jose, for this detailed answer. We have less than 1 minute left. Yeah, okay. How do you deal with latency in data processing and storage? How do you deal with latency? So it depends really about what do you mean by latency? Because sometimes we have SLA. So when you start a project, okay, every project will have either large SLA, like if you are doing a batch mode, or if you are working a streaming mode, or sometimes you can, streaming mode is, you have to, even though if you receive information quite frequently, you should know that using Spark streaming, you should expect some I would say some seconds in order to process the data. So we are not, so in any big data architecture, I doubt that we can process the data in milliseconds, okay? Even though you can process the data in memory quickly, but you have to process the data, and this will take some time, okay? So for streaming use cases, you should expect 5 to 4 seconds, I would say, from end to end, by the time you receive the data, and by the time you are really feeding the last table, so exposed to BI or whatever kind of application. Okay, now, between batch and streaming, we have also a scenario in between that resemble to CDC, change data capture or some. So is that you are receiving files, I would say, on an ad hoc way, like applications are just pushing events in the format of files, and you would like to process files as soon as they arrive to the Azure storage. For that, you can use still one capability in Databricks called autoloader. So using autoloader, as soon as a file is put on the storage account, it's automatically processed by by Spark Stream. So it all depends on SLAs. And if you use autoloader, it will simplify a lot, because if you don't use autoloader, you can still use capabilities of Azure, event-driven, still event-driven. Okay, using autoloader will do a lot of configuration behind the scenes. So all what you have to do is what we can call set and forget. Okay, so working with batch here, latency is something that I would say you will not care about. Working on streaming, latency should be expected, some seconds, for sure, not under 1 second. And the more data is complex, the more latency it will take. Autoloader is really the best approach, in my opinion, when it's about to process files as they arrive. Hope I answered your question. Jose or Tony, do you have something to add on top of what I said related to latency?
I mean, it depends always, for sure. We have, yeah, maybe if you can go, Tony.
It's okay. I was going to say the answer to this is always it depends, right? It's a typical consulting answer, unfortunately, with latency. But things like the way in which you load the data. So having something like some form of metadata-driven ingestion framework that allows you to load at speed and at a performance level that's right for the data using Delta, right, or Lakehouse, is all of these things are actually going to help you in ignoring the latency. You can't prevent it, but you can in certain cases either ignore it or accept it because it's at the right level for the given data source, right? I don't like to say we ignore anything when it comes to latency, but there is an inevitability about moving stuff from A to B. There is a latency involved in doing that, and sometimes if you're talking about very, very large data sets on ingestion, there is going to be a latency. So it's really about maybe then breaking that down, maybe using things like Delta and Optimize, for instance, so that it's actually doing the performance enhancement for you behind the scenes without you doing anything, right? Well, you have to configure Optimize, obviously, but there are certain things that you can do to make the latency be less relevant. What I was going to say.
Yeah, and another question is that another answer, like consulting answer, should be like avoiding bottlenecks will be the best path. But for sure, always when we are talking about data, we will find some bottlenecks and trying to figure out where we need to process in batch or in real time to do a Lambda architecture, for example. This is going to be the best approach, finding the ways that we are not painfully impacting in the infrastructure or the services that we are using, increasing services, and also increasing the performance of the transformation that we are doing rather than to do the transformation massively. So this is kind of the challenges that we can face and the best practices that we can find.
So thanks, Jose. Thanks, Tony. I think with that we will close this. Session. So thank you everyone for having attended this session. So our migration week will continue. So tomorrow we'll be speaking about ETL and how to migrate from some ETLs on-prem to Databricks, and on Thursday we'll be speaking about enterprise data warehouse. Thanks again. You will receive all the materials and the recording in the next couple of days. Bye-bye.
Thank you.